Let's take a look at the rest of the objects in the model to see what else we have to build. We have a cube, a cone, a cylinder, a sphere, and your name. I can tell you that all of the objects are based on the 8-foot square cube, so it's an 8-foot diameter sphere, etc. Note the placement of the objects in relationship to the floor grid. By the way, feel free to use any colors you want for your objects. I'm going to open the file back up and switch to top view in order to start with the cube. Actually, I'm going to go to wireframe because this gives me a better view of where the wall and the floor meet. I'm going to draw an 8-foot square, starting here and going to there. It's lined up with the floor. And then I'm going to extrude that 8 feet. Then switch to isometric, back to OpenGL, in order to check the work. Looks good. If we look at front view, I'm going to change the color of the cube here. You'll see that the cube is in fact sitting on top of the floor, so extruding the floor minus 6 inches was a help. Back to top. The cylinder is simply an 8-foot diameter circle extruded 8 feet. The sphere and the cone are slightly more complicated. If you think about it, you can't really extrude them. So we'll need to either create them through the digital equivalent of lathing or use the built-in 3D object. Let's do it both ways. We'll start with the cone. Select the cone tool in the 3D modeling tools. Click to establish the center. Enter the height of 8 feet and drag to establish a 4-foot radius. And that's it. Now let's create the cone another way by sweeping, which is the digital equivalent of lathing. Switch to front view and wireframe, and use the polygon tool to draw half a cone using the grid as a guide. Now switch to an isometric view, back to OpenGL, and either position the triangle in the right place, or remember to move it into place after you've swept it. So select the triangle and then use the model sweep tool, making sure that the arc angle is 360 degrees and the segment angle is low, 3 is fine. Click OK, and you'll see that the sweep tool takes the shape that you draw and revolves it around itself. In this particular case, it's probably easier to just use the cone tool, but the sweep tool will come in handy for more complicated shapes. You could sweep half a circle in order to get a sphere, but let's just use the sphere tool. And then switch to front view. everything defaults to 0 or the origin unless told otherwise. So we're going to need to move the sphere up into place. It's currently 4 feet below the floor. This is an 8-foot cube, so we'll need to move it up 12 feet. Okay, looks good. The final object is your name. We're going to switch to a front view, use the type tool to type your name, make it large enough to make sense within the context of this model, and choose an appropriate font. In order to extrude the text, you'll need to convert it into 2D shapes rather than text. For this, use the Convert Text to Polylines tool. Now you can simply extrude it. Uh-oh. Extrusion doesn't work on groups. You can extrude multiple objects at the same time, you just can't have them in a group. So, let's ungroup the text, and then extrude it. 12 inches is probably good. Make sure that it's solid, and then move it into the proper vertical position, which is sitting on top of these objects. Now, switch to top view, and rotate the text 45 degrees. And then move it into position over the cube. To complete the model, give everything a color. Now, let's set up the model for rendering. For our purposes, we're going to want to center the model in the origin. So switch to top view, and group everything together. And then move it so that the center of the model is roughly at the origin. This doesn't have to be exact, and models don't always need to be centered on the origin, but it does often make things less confusing. Now, switch back to an isometric view. Since I want to create a PDF, I'm now going to turn my page boundary back on. So that I can see how the model will fit on the page. We've been working in orthogonal projection this whole time, but now let's switch to perspective. Your model may not look anything like this. Yours is more likely to look like that or something. So use the flyover tool and zoom with your mouse in order to center the model inside the page border. This can be a little tricky, so just keep adjusting as needed. Once you're happy with your view, save it using the Saved Views tab, in the view bar. The saved views function is really handy for saving any views that you find useful while working. The last step before rendering is to add some light. We're going to light this model very simply with one light. Switch to top view. And you'll notice that we're still in perspective, which we don't want to work in. The easiest fix here is to go to top plan. Top plan can never be in perspective, so switching to it is always a fast way to get back to orthogonal view no matter where you are. We're going to insert a light by going to the visualization palette and using the light tool to insert a light in the point light mode, which is basically just a bare bulb. Click to insert the light, and then you may get a pop-up box here. If you do, click Point Light Specs, and if you don't, in Object Info, the same information is available. Select the distance fall off as smooth. I hope that you all know from another class that in real life, light gets dimmer the farther away you are from the bulb, but in digital land, anything's possible, so the default is for distance to have no effect. The realistic setting attempts to mimic the real-life fall-off, which is pretty drastic, and smooth is a compromise in the middle. Switch to front view. You'll notice the light disappears. That's because the default in Vectorworks is for lighting objects to only appear in wireframe. So we're going to switch to wireframe. Select the light and then move it up about halfway into the drawing. Then switch to your saved view and run Final RenderWorks, which will take just a second to render. Well, this looks a little dingy to me, so I'm going to select the light and do something you can't do in real life. I'm going to turn it up to 200 and run RenderWorks again. Hey, that looks better. So now we've built the model, lit it, positioned it in perspective, and now we can export it as a PDF. So simply File, Export, Export PDF. You can leave all the defaults the same. The PDF file will default to the name of your Vectorworks file. And when you click Save, you'll notice it always re-renders as it's saving. So it'll take a moment for it to actually export the PDF. And there you have it. The project is now finished, and you can turn it into web courses. You are welcome to turn in the project just like this. However, as an encore, if you're interested, you might want to play around with applying textures to your object. In order to do that, double-click on the group in order to enter group edit mode. And now is also a good time to switch to OpenGL. Select an object, and then in Object Info, click on the Render tab. You'll see under Texture, you have a choice of None, Class Texture, or Texture. If you select Texture, this dialog will pop up. If you click on it, if you've downloaded textures when you installed your program, you should get a menu that looks like this. Under Vectorworks Libraries, Defaults, RenderWorks, Textures. It's entirely possible that you won't have this, or you only have just the default textures if you haven't downloaded them. If you don't have them, don't worry. Just turn the project in like it is. We are going to be using textures later in the semester, so you are going to want to make sure that you've downloaded them. But no harm, no foul right now. But if you do have them, you might just want to play around with the textures. So what would happen if we had a concrete sphere, for instance? Or a carpet cylinder. Or maybe metal can be fun. Let's do corroded mesh. And then here we can have we'll do another metal. How about corrugated? You can, this looks like the world's smallest corrugation. You can control the scale. Whoa, it just disappeared. That's very strange. You'll notice the size is getting bigger. Feel free to play around with those however you want. And then if you run Final RenderWorks, you'll see that you can get some pretty interesting things, particularly the cone, which is made out of, appears to be made out of metal mesh now. So if you're interested, play around with those and then resave or re-export your file as a PDF and turn that in. You're welcome to turn both of them in, or just the first one. All right, thanks for participating in Project 1. See you next time.